Can you guys see my shared screen?
Yes, yes.
Okay. Right. Let's look at this question. Question 4 on friction. Right. As mentioned in your test, you can expect three questions: motion, power, and energy. That's module one. Module three, forces, and module four, friction. Right. I have left out what is this? Beams. Right. Statics. That's module two. Right. So you have about three questions. Each question will be 20 marks. So your test would be out of 60 marks. All right.
Okay.
Now let's look at question 4.2. Question 4.1, give three advantages of friction that you'll be able to answer looking at the notes I sent on friction. All right, so that you can do on your own. Now 4.2 reads as follows. A body with a mass of 0.6 tons is placed on an inclined plane making an angle of 25 degrees with the horizontal. Okay. The coefficient of friction is 0.36. A force P at an angle of 30 degrees to the plane is required to pull the body up the plane. Right. Now, just like when we looked at balanced and unbalanced forces for the first module, right, so the first thing you do for such cases is you draw a free body diagram. Right. So remember when we did motion, power, and energy, the parts where we look at balanced and unbalanced forces, I did mention that the knowledge that you gain there, you are definitely going to use under friction. Right? The only difference really is that under friction, we always assume we assume that object is moving at constant velocity. Right? For friction, we always assume that the object is moving at constant velocity unless stated otherwise. It's very important for friction. Right? It's important to note that for friction, this is always the case. Right? You assume that the body is moving at constant velocity. Right? So now, when the body is moving at constant velocity, what does that tell us? Hello? So a rhetorical question.
Um,
If a
um,
body is moving at constant velocity, what does that tell us? What does it suggest?
uh, an equilibrium?
Yes, it means the vector sum of forces is equal to zero. That is correct. It means um, the sum of forces in the x direction we take as being equal to zero. Sum of forces in the y direction we take as being equal to zero. All right. But like I said, unless that has been stated otherwise. All right. So by stated otherwise, you'd be given, say, acceleration, or you'd be told that the object is accelerating either up the incline or down the incline. Right. If that hasn't been stated, right, you always assume that the object is moving at constant velocity. Right. So that's number one. Now let's draw the free body diagram for this problem. Right, you have an object, it's on an incline. This is yeah, that's right. Right, so the object is on an incline. Right, uh,
Sorry, sir. One.
uh-huh.
There's people waiting to be let in the meeting.
Added in the meeting. The meeting doesn't have restrictions. None of you here were added by anyone, right? Hello.
No, no.
Exactly. The meeting doesn't have restrictions. Everyone should be able to get in on their own. There's absolutely nothing I can do on my side because, as you can see here, see, there's no one that needs to be admitted. So the problem is on their side. Just tell them to either change devices, right? If they're using their cell phones, try to use their laptops instead. Nah. Right, so we have an object. The object is going up the incline, right? They told us the object is going up the incline. All right. So this is going up the incline. We have this. All right. So remember, we have the components of the weight that's parallel, that's perpendicular to the plane, and one that is parallel with the plane. So here we have FG perpendicular. This one is perpendicular to the plane. That one is mg cos theta. Right, the theta is that angle. And then of course you have one that is parallel with the plane. That's mg sine theta. And then of course we get normal force, which is a contact force. We have the normal force here. All right, so these are the three forces that when an object is in contact with a surface, these are the three forces. Well, with an inclined surface, these are the three forces that the object is subjected to. Right? Before even you look at if there is a force being applied, right, whether the object is going up the incline or down the incline, right, it is important to note that as soon as you have an object in contact with an inclined surface, these are the three forces that you have right away. Right. Now you look at the other forces that this is being subjected to. Inclined plane. Right. The coefficient of friction is this. A force P at an angle of 30 degrees to the plane is required to pull the body up the incline. So this is going up the incline, and a force P is necessary for that to happen. And that force P, right, is pulling the object at an angle of 30 degrees to the plane, right? So the force P is making an angle of 30 degrees with this plane, right? Now they said a force P at an angle of 30 degrees to the plane is required to pull. Right? It's very important you establish if they used the term pull or push, right? Because remember, To push is to do that, right? To pull is to do that, right? So the force being used being a pulling force or a pushing force is very important that you establish. So here they said this is being pulled, meaning the force is going in this direction. Right, so you have a force P in this direction. Right, so a pulling force going in this direction. That force is force P. That is our applied force, and that force is making an angle of 30 degrees with the plane. Right. What else? Right,
Okay.
that's it. You have a question? No question.
No, sir. No.
Right. So if this is being pulled in this direction, it's being pulled up the incline. Right. What is that? What is the direction of friction going to be?
The opposite way, sir.
So the opposite of motion. So if the motion is in this direction, it means friction is in the opposite direction. So we have a force of friction here, or a frictional resistance, right, going in that direction. So we have FR, right, frictional resistance going in this direction. Right, now like we said, here nothing suggests that this is accelerating, so we assume it is moving at constant velocity. So because it is moving at constant velocity, it means it is not accelerating. Hence, I am not showing the direction of acceleration here. Right, now the force P, which is the applied force, right, the force P is an oblique force. You guys remember what we do with oblique forces, right? We have to resolve them into its components. So we resolve this into its components. The angle that we have is a reference from the x-axis, meaning that the horizontal component will be in terms of cos, and the vertical component will be in terms of sine. So we have this component, and we have this component. Right. So P in the x direction will be P cos 30, and then P in the y direction will be P sine 30 degrees. Right. And then we'll be able to use the components of P in applying conditions of equilibrium, because it's the components that are parallel with the forces that are in the x direction or y direction. Right. That is why resolve components, we resolve oblique forces into their components, right? Because we are trying to get all the forces to be either parallel with the y-axis or parallel with the x-axis, but they have to be parallel with some axis. Right. Now let's see what else we've been given here. So we have the mass. Right, the mass is 0.6 tons. What is 0.6 tons in kilograms?
600.
So 1,000 kilograms. So convert from tons kilograms to multiply by 0.6 times 1,000 is 600 kilograms. Right. Angle theta is 25 degrees. And the statement coefficient of friction is 0.36. Right, that is it. Right, that is everything that we've been given. Now we can look at the questions 4.2.1. They say calculate components of P parallel to the plane. Right, the component of P parallel to the plane. Now you have two components here. You have this component, you have this component. Now, which of the two components is parallel with the plane? Is it PY or PX?
The X.
Exactly. All right, so the question is to calculate the component of P that's parallel with the plane. Here's the plane. So this is the component of P that's parallel to the plane. So they want us to calculate PX. All right. All right, PX is equal to P cos 30. And what is cos 30 equal to?
It's 0,866.
0.866 P. Right, that is what they're looking for here. Right, we obviously do not have the value of P, right? But if you look at the marks as well, the mark allocation is 1 mark, meaning that they don't need us to do too much, meaning this is just what they are looking for, right? The equivalence of the component of P in the that is parallel to the plane, which is this here, 0.866 P. All right. 4.2.2. Calculates the gravitational component parallel to the plane. All right, the gravitational component parallel to the plane. Which component are they referring to here? The gravitational component parallel to the plane.
That would be the it is the sine.
Right, that's F
Components.
parallel. Right, remember you have two components of the weight. You have one that's perpendicular to the plane, that's FG perpendicular, and then you have one that is parallel to the plane, that's FG parallel. So if they want us to calculate the gravitational component parallel to the plane, right, it means this is what they're looking for, FG parallel. Right, similarly, if they want you to calculate the work done by the gravitational component parallel to the plane, this is what you use. Right, and then of course they'd have to give you the displacement or the distance of the inclined plane. Right, so they're looking for FG parallel, which is mg sine theta. The mass is 600. G is 9.8 sine, and theta is 25 degrees. All right, so this is 600 times 9.8 times sine 25. And what are you guys getting there? I'm getting 2484,995 newtons.
It the same, sir. The same.
Right. All right. Take note for engineering science. Right. G is 9.8. We do not use 9.81. Right. This is also in your instructions. Right. When you get to an assessment, the 10 minutes you get to go through the question paper includes having to go through instructions. So make sure you go through instructions. Right. If, as per the instruction, you are told to attempt each question on a new page, then that is exactly what you must do. Right? It means if there are 3 questions and you have to you have to start each question on a new page. It means once you are done with question 1, in starting with question 2, you have to start question 2 on a new page. Similarly with question 3, once you're done with question 2, you start question 3 on a new page. Right? And then as per the instruction, you are always told to use G as 9,8. Right? So if you use G as 9,81, you will lose marks for that because it will mean you have ignored instructions. Right, 4.2.3 calculates the gravitational components perpendicular to the plane. Right, obviously that is FG perpendicular. So FG perpendicular is mg cos theta. Mass is 600. G is 9,8. And this is cos 25. Right, cos 25. I am getting here 5329,090 newtons. Right, you guys getting the same thing?
Yes.
So that's FG perpendicular. And then now 4.2.4, they now want us to calculate the magnitude of P. That's 4.2.4, calculate the magnitude of P. So now they want us to calculate the magnitude of P. Right. In calculating the magnitude of P, we've already established that this is moving at constant velocity. So in calculating the magnitude of P, you simply apply conditions of equilibrium. Right, you simply apply conditions of equilibrium, meaningly say the sum of forces in the x direction, we know that is equal to 0 because this is moving at constant velocity. Right, so now we look at forces in the x direction. Forces in the x direction, you have this component of P that's parallel to the plane. You have this component of the gravitational force that's parallel to the plane. You have the frictional resistance. Right, those are all the forces that are parallel with the x-axis. Right, so we have P cos 30. P cos 30 is equal to, so essentially we have 0,866. So we can just call this 0,866 P. Right, that's the only force that's headed in the positive direction. Right, the other two are headed in the negative direction. So we say minus FR minus FG parallel. Okay, maybe let me do this first. Give context. So this is going to be Px minus Fr minus Fg parallel is equal to 0. That is the sum of forces in the x direction. Right, we have this one going in the positive direction, hence we take it as being positive. And then we have the other two going in the negative direction, which is why we take it as negative. Right, so now you substitute Px we calculated and got 0,866 P minus Fr, right? Minus Fr. Now we haven't been given the frictional resistance here. right? What we've been given instead is the coefficient of friction, which suggests that there is some considerable friction, right, between the two surfaces. Now, the normal force and the frictional force both are contact forces, right? Meaningly, we only get those forces when two surfaces are in contact, right? So the two surfaces obviously being the object and the inclined plane. As soon as the two surfaces come into contact, then we have the normal force and the frictional force. And the relationship between the two, right, is that the coefficient of friction is equal to the frictional resistance divided by the normal force, right? This comes from the fact that the frictional resistance is directly proportional to the normal force, right? And then in getting rid of the proportionality sign, you introduce a constant. And in introducing a constant, right, replacing the proportionality sign with an equals to sign, in introducing a constant, that constant becomes the coefficient of friction, right, times the normal force, right? So this relationship, or this, comes from this here, the frictional force being directly proportional to the normal force, right? So that is to say that we are able to um, replace the frictional resistance with mu times the normal force, right? So this will be, instead of frictional resistance, because the frictional resistance is equal to mu times the normal force, right? We replace that with mu times the normal force, right? And then minus Fg parallel, which we calculated, and this is what we got. So minus this, and all of this is equal to 0, right? And then of course this is 0.866p minus mu is 0.36, right? So here we can have 0.36 times the normal force minus the 2484,995 is equal to 0. 995 is equal to 0. All right. And then we can take this as our first equation, right? Remember that when you have two unknowns, it means you need two equations, right? Then you solve them simultaneously to establish what those two unknowns are, right? Now, our second equation here is going to be in the form of the application of Newton's laws of motion, right? This one in particular. Sum of forces in the y direction is equal to 0. That's the other condition of equilibrium, as per Newton's third law of motion, right? Now we look at forces that are parallel with the y-axis. Forces that are parallel with the y-axis, it's the normal force, right? The component of P that is perpendicular to the plane, that's Py, and then of course Fg perpendicular, right? So these two are headed in the positive direction, so we're going to take them as being positive. This one is headed in the negative direction, so we are going to take this one as negative. Right, so you have the normal force plus Py, then minus Fg perpendicular, all of this equal to 0. Right? Normal force remains the same, plus Py, which is equal to P sine 30. Right, so this is P sine 30 minus FG perpendicular. We also calculated this. And this is what we got. All of this is equal to 0. All right, now what is sine 30 equal to?
It's equal to 0.5.
0.5. So this essentially is normal force plus 0.5 P minus the 5329,090 is equal to 0. Right. Now, here we are looking for the force P. Right. So it is going to be convenient that we make the second to be in terms of the normal force, or to make the normal force the subject of the formula, right? So that we can then take the second equation and substitute it in the first equation. So meaningly here, because we are looking for force P, we aren't necessarily looking for both force P and the normal force, right? It's convenient that we express the second equation, right, to be in terms of P, thus making the normal force the subject of the formula. That way, you can simply take the second equation and substitute it in the first, right? Once that is done, the only unknown will be force P, which is what we are looking for. So here, right, we make the normal force the subject of the formula. So you take both of these terms and transpose them to that side. So here you will have positive positive 5329,090, and then the 0.5 P becomes negative 0.5 P, and then we take this as our second equation. Right, we have two unknowns, now we have two equations, so they can be solved simultaneously. Right, at this point you can simply say substitute the second equation into the first equation. Right, so you are taking this and substituting it into the second equation. Right, so the first equation is 0.66 P minus 0.36 into the normal force, right? So the normal force, as per the second equation, is equal to this. So now we substitute this in there. Right, and then minus the 2484 minus this is equal to 0. Right, so when we substitute the second equation into the first, this is what we get. Right, then now you get rid of the parentheses. So we'll have 0.866 P. Now in getting rid of the parentheses, we say the negative 0.36 times this. So negative 0.36 times the 5329,090. I'm getting here negative 1918,4724. Right, and then of course you then multiply the negative 0.36 by the negative 0.5 P. Right, so the two negatives are obviously going to cancel each other out, and we get positive. So 0.36 times 0.5 gives us 0.18 P. and then this one remains the same. All right. Now that we've gotten rid of the parentheses, we can now just look at like terms. All right. By like terms, I mean this isn't like with that. So we add those 0.86x plus the 0.18 is equal to the 1,046p. Right. And then, of course, you add these ones, this with that. So negative 1918,4724 minus the 2484,995. And I'm getting here negative 4403,4674 is equal to 0. All right. And then in solving for p, you transpose this term to that side. All right. So you will have 1,046p is equal to, and then when you transpose this term, it becomes positive. Now you make p the subject of the formula by dividing by its coefficient. And then doing so, divided by the 1,046. Right. So this divided by the 1,046 gives us 4209,816 newtons. Right. And that is how you would attempt such a question. Right. If you look here, we have done exactly what we've been doing, right, in module 1, right, with the difference of having to assume that the object is moving at constant velocity, right, meaning that the acceleration is 0. That's the only difference, really. Right. Otherwise, if you look at the approach, the very same. Any questions?
Not. I don't have any, sir.
What about everyone else? Before we move on to the next one. No questions. All right. So as far as questions on friction, people, all right, that is how you attempt. Right, that is how you attempt them. Now, as much as friction for the most part is easy, right, some exercises do require you to think a bit. Right, aside from typical questions like these ones, where, like for instance, this one, right, you simply just draw your free body diagram, right, and there isn't much thinking you have to apply really after, right. You base all your calculations on how you've drawn your forces on your free body diagram, right. But then you get questions like these ones, where it is required that you understand um, things like angle of repose, angle of repose, right. It's also known as angle of rest. Maybe you are familiar with this term. It's angle of rest, angle of repose. That is the same thing. Right. And then both these are equal to the angle of friction. Right. So some of the questions you are required to understand how to approach the question if the angle that we have, the angle of incline, is equal to the angle of repose. Right? But as soon as you understand how to use this information, then it becomes easy. Right? Let's look at the statements. A body with a mass of 80 kgs is sliding at constant velocity down an incline without any external force acting on it. The angle of inclination is 30 degrees. Right? Now, one thing we need to understand here, they said you have a body with this mass sliding at constant velocity down an incline without any external force, right? So meaningly, there was no force that was applied, right, to this body for it to start moving down the incline. Now, what does that suggest? Let's draw a free body diagram. Right. Okay. So this is moving down the incline, meaning it's moving from the top down the incline. Right. So before this even starts moving down the incline, like I said, you have the three forces that will always be, that the object will always be subjected to as long as it is in contact with the surface. Right. That is the component of gravitational force that's parallel to the plane and the one that's perpendicular to the plane. Right. We have FG perpendicular, that's mg cos theta, and FG parallel, that's mg sine theta. And then you have the normal force. And the normal force, right, these are the three standard forces that as soon as two objects come into contact, right, when two surfaces come into contact, right, they are subjected to these forces. Right. Now they are saying that this is moving down the incline without an external force acting on it. The angle of inclination is 30 degrees. Right. So you have theta here that's equal to 30 degrees. Now, when an object slides down the incline without an applied force having to act on it, or without any force being applied on it, what that suggests is that the inclined plane, right, is such that it is at an angle of repose, right? It is at the angle of repose that the object is able to slide down the incline on its own, right, without any applied force, right? So it is to say that when you've been told or when you've been given a scenario where the object is sliding down the incline without any external force, that suggests that the angle of incline is such that the object is able to slide down the incline on its own using or because of the gravitational component that is parallel to the plane. All right, so this is moving down the incline because the angle of incline is such that it is an angle of repose. And because this incline surface is at an angle of repose, that is why this object is able to move down the incline, right? Because of this component of the gravitational force, right? This scenario only happens, right? This can only happen if the angle of incline is the angle of repose. All right, so the angle of incline here is the angle of repose. Now, having our incline be the angle of repose suggests, well, aside from the fact that the object is going to move down the incline because of these components of the weight, it also suggests that tan angle of friction or angle of repose is equal to mu, the coefficient of friction. Right? In such a scenario where the angle of inclination is actually equal to the angle of repose, right? It suggests that the coefficient of friction is equal to this here, tan angle of repose. Right? It's only in this situation where the coefficient of friction is equal to the angle of repose. Right? So here we are saying in this scenario in particular, the angle of inclination that's theta is equal to the angle of repose or angle of rest. Right. Therefore, meaning theta is equal to the angle of repose. Right. Any questions here? Very important that you understand this part. Because it helps just in case you have to calculate the coefficient of friction. Right, knowing that the angle you have is the angle of repose, you can simply use this relationship to calculate your coefficient of friction. Right, so once it is established that the object is moving down the incline on its own, hence the angle of inclination is essentially equal to the angle of repose. Once that is established, right, then it means this is the relationship you have. Right, hence why it is important that you establish if the scenario you're looking at is the object moving down the incline. If it is it moving down the incline on its own without any external forces, or is there an external force being applied? If there is an external force being applied, then You don't have all of this. Right? This is only satisfied if this is moving down the incline without any external forces being applied. Are we clear here?
Yes, sir.
Right. Now let's look at other forces here. Right. So this is moving down the incline, meaning the motion is in this direction. And then opposing motion, you have frictional resistance. And we have FR, opposing motion. And that is it as far as our free body diagram. Now, they did indicate that this is moving at constant velocity, meaningly conditions of equilibrium are being satisfied here since there is no acceleration. Right? Now, let's look at what else we've been given. The mass. Mass is 80 kgs. Theta is 30 degrees. But we have established that our theta is also equal to the angle of repose. Therefore, meaning angle of repose is also equal to 30 degrees. Right, 4.2.1. Calculate the weight component perpendicular to the plane. Right, weight component perpendicular to the plane, that's FG perpendicular. So FG perpendicular being equal to mg cos theta is equal to mass is 80 kgs, g is 9.8, cos theta is 30 degrees. And what is this equal to? 80 times 9.8 cos theta, which is 678, 964 newtons. Are you getting the same thing here?
Yes.
Right. Right. So remember to always round off to 3 decimal places. Right. It is said so in the instructions as well. So, because sometimes you can forget to read instructions, just make it a norm that you round off to 3 decimal places always. That way, even if you have forgotten to go through the instructions or you miss that particular instruction, but because it is already built in your brain that you round off to 3 decimal places, right? It won't necessarily matter that you missed that part of the instructions. Right. 4.2.2, the weight component parallel to the plane. Right. That's obviously FG parallel. So FG parallel being equal to mg sine theta. The mass is 80. G is 9.8. Sine theta is 30 degrees. Right, so this times sine theta is 392 newtons. Are we getting the same?
Yes.
Right. 4.2.3. Calculate the frictional force. Right. Now, what is the frictional force going to be equal to here? Look at your free body diagram, considering that this is moving at constant velocity. What is Fr going to be equal to?
So the force of the parallel force.
Yes. So, because the conditions of equilibrium here are satisfied, meaning that the vector sum of forces is equal to 0 because there's no acceleration. It means the sum of forces in the x direction are equal to 0. Sum of forces in the y direction also equal to 0, meaning that forces going in that direction are equal to forces going in this direction. Forces going in that direction are equal to forces going in that direction. So if that's the case, along the x-axis, there's only two forces. There's Fr going in the positive direction, and then you have Fg parallel going in the negative direction, meaning that this is equal to that. Right? So as per our free body diagram, Fr is equal to Fg parallel, and Fg parallel is equal to 392 newtons. Any questions on this one?
No, sir.
Pretty straightforward. 4.2.4 calculates the coefficient of friction, right, of the plane. Right, like I said, right, in drawing your free body diagram, right, you establish if the angle of inclination is equal to the angle of repose. If it is, then it means we have this relationship. They want us to calculate the coefficient of friction. That's mu, right? So you can simply use this relationship there, right, to calculate mu. Right, tan angle of repose is equal to mu, and then of course we are looking for mu, so we make mu the subject. Tan angle of repose is 30 degrees. So tan 30 is equal to 0.577. Right? Coefficient of friction is dimensionless. Right? It has no dimensions. So the answer here is simply 0.577. Are you guys getting the same thing here?
Yes.
Right. 4.2.5. The external force, calculate the external force required to pull the body up the incline at constant velocity. Right. So now the scenario is changing. Right. They now are saying there is a force being applied that pulls the body up the incline at constant velocity. Right. It means our free body diagram is going to be a bit different now. Mm. Right. This is moving down the. I mean, it's moving up the incline now. So if it's moving up the incline, in its direction of friction is going to be different. So friction, remember, always opposes motion, meaning friction is going to be in that direction now. Right? This is moving up the incline. As they said, the external force required to pull the body up the incline at constant velocity. So remember, this is a pulling force. And because it's a pulling force, it means it will be in that direction. Did they call this? So they didn't call it anything. So let's just call it FT. Total force applied. We have a pulling force. This pulling force is enough to pull the object up the incline at constant velocity. Right. Right. That is all we have. Right. So now we need to calculate this pulling force FT. That is enough to pull the object up the incline at constant velocity. Right. So how do you think we are going to calculate this force FT? Looking at our free body diagram. Bearing in mind that the object is moving at constant velocity.
Using the sum of the x and sum of the y.
So conditions of equilibrium. Right. So remember, if this is moving up the incline at constant velocity, it means the conditions of equilibrium are satisfied here, seeing that there is no acceleration. No acceleration means the vector sum is equal to 0. F net is equal to 0. If F net is equal to 0, it means forces going in this direction is equal to forces going in that direction. Right. So meaningly here, it simply means Ft is equal to Fr plus Fg parallel. Right. Forces in the positive x direction are equal to forces going in the negative x direction. Right. And this we calculated. Fr is 392 plus Fg parallel we also calculated. We also got 392. Right. It means this is 392 times 2, which is 784 newtons. Easy peasy. You want to talk about easy? That's friction. Any questions?
None from me, sir.
What about everyone else? Now the free body diagram, right, is for you guys to understand. It is us breaking down the question essentially. Right, that is how any engineering practitioner attempts or approaches such problems. Right, by drawing your free body diagram. Free body diagram will solve half the solution for you. Right, but you don't necessarily have to draw it right on your answer books. It is convenient though. If you look at any of my solutions, right, if it requires that I draw a free body diagram, I always do. Right, now you don't necessarily have to draw it on your answer scripts. You can draw it on the question paper. Unless you're someone who is able to work this out in their minds. I wouldn't suggest it, But if you are someone who's like that, then you can do that as well. But I would advise that you guys become friends with the free body diagram. It helps a lot. Any questions?
I don't think there's any questions, sir.
Right.
Unless someone.
With friction, like I said, if you understand balanced and unbalanced forces, that is essentially what friction is. Right. With additional or with quantities and terms that are more specific to friction. Right. But friction is a part of balanced and unbalanced forces. Right. Mm, let us do. Let us look at this one. This question is on conservation of momentum. I saw one of you asked if we could do a question on conservation of momentum. This is another easy one. Conservation of momentum. Perhaps that's why it doesn't carry a lot of marks in assessments. It's pretty straightforward. Right, with conservation of momentum, before even looking at the question, right, we will always be looking at two objects that are in a collision. Right, we look at the momentum before the collision for both objects being equal to the momentum of both objects after the collision. Right, so mathematically, we say essentially since you have two objects, the one object is going to be named as 1, the other object we are going to name as 2. So as far as the equation we use in conservation of momentum, we say the initial velocity of 1 times the mass of 1. Right, remember momentum, right, is equal to velocity times mass, because momentum is essentially or how you even what is this thing? How you even what's this word I'm looking for? How you even define momentum? Is momentum is essentially a mass in motion, right? If you have a mass and it's in motion, you have momentum, right? So the initial velocity of 1 times the mass of 1 plus or minus the initial velocity of 2 times the mass of 2 is equal to the final velocity of 1 times the mass of 1 plus minus the final velocity of 2 times the mass of 2. Right? This is the one and only equation you are going to use here. Now here it is plus or minus, right, because of direction. Right? If say you are looking at two objects, one is headed east and one is headed west. So the one that's headed west is going to be negative. That is why we say plus or minus here. Otherwise, you can just say plus. And then, of course, taking into consideration that we do consider direction. Right? If this one is headed west, then obviously you would make this one negative. But I'm just saying that is where this comes from, the plus or minus. Right? You don't necessarily have to write it as plus or minus, right? But that is where it comes from. I understand some of your textbooks, this is what they have. Right? Plus or minus here. The plus or minus is based on the direction of this. Right? Now let us look at this exercise. Right, so we're going to write down what we've been given. say conservation of momentum. And point 3, let's write down what we've been given. That's an object with a mass of 30 kgs and a velocity of 12 meters per second collides with a mass of 14 kgs and a velocity of 5 meters per second, 5 meters per second coming towards it. After impact, the masses move off together with a common velocity. All right. So we are going to take the 30 kg mass as 1 and the 14 kg mass as 2. All right. First things first, the equation as per conservation of momentum, U1 times M1 plus U2 times M2 is equal to the final. Now, take note here. They said after the impact, the masses move off together with a common velocity, meaning that the final velocity for both is the same. All right. So because it is the same, we don't necessarily have to call the final velocity for each of the objects V1 and V2. We can simply just call it V because it is the same. Right, so meaningly here, we can simply say the final velocity times mass 1 plus the final velocity times mass 2. Right, so this is to indicate that they share the same velocity, right? Which means you can actually write this as is equal to, then you take the common factor here, which is V into M1 plus M2, right? So you don't necessarily have to write it like this. Right? As soon as you have established that the velocity of the final velocity of the two objects after the collision is the same, right? This is what it means. Are we clear here?
Yes, yes.
All right. So let us write down what we've been given. So you have mass 1, which is 30 kgs. Initial velocity of the first object is 12 meters per second. Now notice here that they didn't indicate the direction of this mass, right? Collides with a mass of 14. So mass 2, M2 is 14 kilograms. And the initial velocity of 2, mass is 14 and the velocity is 5 meters per second coming towards it, right? So the coming towards it indicates that the two objects are going in opposite directions. Do you see what I mean here? Right. If it is coming towards it, it means one is headed in that direction, the other one headed in the opposite direction. Right. The two objects are coming towards each other. Are we together? Hello.
Yes.
Right. So meaning one is headed east and one is headed west. So it doesn't matter which how you assume or how you assign your directions, as long as one is headed east and one is headed west. So we are going to assume that this one is headed east, so it's going to remain positive, And then meaning if this is headed east, it means this one is headed west. So this you take as negative. So this will be negative 5 meters per second. Right. And then we're also told that after the collision, the two move at common velocity, meaning that final velocity of 1 is equal to final velocity of 2, which is equal to v. Right. And the question is to calculate this velocity. So they want us to calculate this here. This is what we're missing. That is what they want us to calculate. So we already know, or we've already established that this is the case. Right. Now you substitute. Right. U1 is positive 12. M1 is 30. Plus U2 is negative 5. M2 is 14 is equal to V into M1, which is 30, plus M2, which is 14. Right. We are obviously looking for V. In making V the subject of the formula, we divide both sides. Right. By the 30 plus 14 to get rid of it. Divide by this, both sides. And then, of course, you get rid of that, meaning that V is equal to this here. So V is in the numerator of 12 times 30 plus negative 5 times 14 divided by 30 plus 14. So I'm getting positive 6,591 meters per second.
Yeah. Yes.
Right. So what we should take away from this is that, seeing that we assumed that it's mass 1 that's headed east and mass 2 is headed west, because the final velocity is positive, it means after the collision, these two move in the same direction as mass 1. So that is to say that had we taken mass 1 as heading west and mass 2 as heading east, we would have gotten a negative answer here. And that negative answer would be indicating that the two objects are moving in the initial direction of mass 1. All together.
Can you repeat that quickly?
So I'm saying, remember, in the statements, there was no indication of direction. What we knew is that the two objects are heading towards each other. So meaning that one is headed east and the other is headed west. But we are the ones that allocated the direction. We said, seeing that the two are headed in opposite directions, we are going to take mass 1 as heading east and mass 2 as heading west. Right? So the final velocity we got is positive. Right? So because it's positive, it means after the collision, the two objects moved in the initial direction of mass 1. So because seeing that this is positive, it means it is headed east. And the object that was headed east initially, by initially I mean before the collision, was mass 1. Right, so this is what that tells us, that the two objects after the collision move in the direction of mass 1. So I'm saying, had we assumed that mass 1 is headed west, So had we made this negative and assume that mass 2 is headed east, hence make this positive, then here we would have gotten a negative answer, which again would have suggested that after the collision, the two objects moved in the direction where mass 1 was headed. Right? So it's not so much important that this is headed east. What is important is that it is headed in the same direction as the initial direction of mass 1. Any questions?
So yes, so you don't make mass 2 a negative, seeing that mass 2 is heading in the opposite direction of mass 1. So you only take the velocity as minus.
So here we took, right. So if you look here, they said mass 2 is coming towards mass A, I mean mass 1, essentially. All right. But seeing that they didn't specify if mass 1 is heading east or west, essentially we assume or we allocate the directions ourselves, bearing this in mind. Right? I chose for us to say that mass 1 is heading east. Hence, because the two objects are heading towards each other, it means if you assume that this is going east, it means this is heading west. That is why it is negative.
Okay, no, I understand. Yeah, I understand. But in the equation, yeah, so you only take the velocity as going in not going in the opposite direction, but you only take the velocity as minus. You do not take the mass as minus as well.
No, okay, I hear you now. So mass is a scalar quantity. It doesn't have direction. Hence, as far as having to allocate which one is negative, it can only be the velocity, because it's only the velocity where we consider direction as well. So yes, you only allocate the negative to the velocity, not the mass.
Okay, all good, all good.
Okay. All right. Any more questions on this?
I don't think so, sir.
All right. So I sent the solutions to that assessment preparation assessment or assignment. I don't know if people got it. Hello?
It's for the yeah, it's for the questions that were given to us, right? About
Yeah.
forces and friction and
Yes.
moments. Yes, I got it. Yeah.
Yeah. So your test will be similar to those questions. All right. So I am going to be sending you guys more questions for you to practice. But as far as the structure of the test, it will be more or less the same as that assessment prep. Yeah. Now, before we end the session, I want to address any questions regarding Module 1 as well as Module 3 forces, if there are any. No questions regarding the other modules.
I don't think so, sir.
All right. Right. If any questions arise, I am available to answer them in the group. If maybe you attempted an exercise and you're either struggling with it or perhaps you thought you nailed it, but you're not getting the same, so you're not getting the same answer as either the textbook or the marking guideline. Right, you can tell me over the group and I'll have a look at it and send it to the group as well. Otherwise, if there are no more
Okay.
questions, I guess we are done here. I am going to upload this on the channel and send the link to the group for those that weren't able to attend the meeting. All right. Now, like I said, your test, 3 questions. One question is on motion, power, and energy. So the first module. Right. The only real difference between the first assessment and the second assessment is conservation of momentum. So there'll be a question on conservation of momentum as well. It'll be like 2, maybe 3 marks. Right. Otherwise, everything else that we did cover for the first module. And then the other question will be on forces. So module 3. Right. It will be coplanar and concurrent forces, as well as a roof truss or a framework. And then the other question will be on friction. Right. On friction, there will be a lot of marks allocated to theory. So make sure that those notes I sent you, make sure you go through them. Nah. All right. Enjoy the rest of your Sunday, people, and good luck. Now, make sure you pass this one.
Thank you, sir.
Even if you got 0 in the first one, so it's not a train smash, not really. It's not a good thing, but it's not a train smash because the first assessment carries 30% of your CAS mark, and your second assessment carries 70%. So even if you got 0 in the first assessment, if you get 40 out of 70 for this one, you will qualify. All right, if you get 40%. So if you get, say, 57%, yeah, if you get 57% in the second assessment, that will be equal to 40 out of 70. Right, 40 out of 70 means that you have 40 out of 100, which means you will qualify. Right, my point here is that not all is lost. Right, so just make sure you have prepared well for the second assessment and you hit that one out of the park. All right, you kill that one, you qualify. I'll record some videos for the remaining, the remaining modules, and then hopefully, not hopefully, I want to try as best as possible for the week during or in the days leading up to your exam, right? Or maybe a week before, right? We'll work out the details for us to have a live session, right? In fact, I intend on having 2 live sessions, right, where we will be going through a question paper, right? So for both sessions, we'll be going through 2 different question papers, so that you guys are aware of what exactly is expected of you. right, in answering your questions where marks are allocated. No.
Okay.
Right. So all the best, people. We will see each other after the second assessment. Now things are gonna move a bit quicker now, right? Even your marks, right? You should expect your marks like probably a day or two after having written your assessment. Right? Everything is gonna move a bit quicker now because we are right at the end. Yeah. So your marks you should receive about 2 days after writing your assessment. Right? I'll make it a point that I mark your scripts either on the day that you write or the day after. Either way, though, I'll be giving you your marks. Probably 2, at most 3 days after writing. Yeah. All the best. Cheers.